All right, my exponent shortcut. This was my cheat sheet when I was in college, in a sense, and even high school. Not that I used it during tests, but I used to have this for my homework. Had this brought up here because I did a lot of these where I had 2 squared was 4, 2 cubed was 8, 2 to the fourth was 16. You can see 2 to the 5 is 32. I mean, like, teacher, like I may had work a problem like 4 to the fifth power was what? And so I'd go over here and do this 1024. And that was back in the days before we had like calculators that would do all that stuff for us real faster. We may have had the calculators, but we didn't have them. So I kind of used to use this. So I kind of have this that I use a lot for things that I'm doing. So just kind of put that out there. So and what I would do is I'm going to teach a little lesson here about law of gravity. So I remember Wile E. Coyote one time went running off the cliff and so did the road runner. And the coyote fell and the road runner didn't. And as the coyote was falling, he wrote down a law of gravity, and the roadrunner held up a sign said, "I never studied law," and the roadrunner didn't fall. But we know that's not true. But anyway, law of gravity, law of exponents. First law of exponents says this: if I have two numbers multiplied here, the same base, I can simply add the exponents. So this would be like, say I had x squared and x cubed, I could add them together to get x5. And it's kind of the same thing here. If I have one divided by the other, I can just simply take that and subtract the exponents. If this was a 5 and this was a 2, it'd be 5 minus 2 would be 8 to the 3. And then here on this one, and basically a negative exponent just flips it to the denominator. It becomes a positive in the denominator. That's what it means. And anything to the 0 power is 1. Anything to the 0 power is 1. And here, this is kind of like a commutative property. X goes to both the A and the B. So you take the exponent to both of these, law 5. And law 6 is the only time you actually multiply an exponent on an exponent. And I call it an exponent on an exponent because you have a to the x to the y power. So you're going to have a to the x y times, which is exactly the definition of a multiply, kind of like a grouping thing. And here, this is just like 5, except instead of a multiply, it's a divide. It is commutative. It goes to both. And this one here just basically is kind of the fancy way to say that when you take the a value and you square it, it's going to be positive.